Iman.
Yep, true.
Okay. Yeah. Recording started.
Right. We welcome all of you to this lecture series for propagation of statistics education and research organized by Calcutta Statistical Association as a part of its outreach program. Today's lecture marks the beginning of the third session in this online lecture series. In the first session, we had three lectures delivered by Professor S.P. Mukherjee, Professor Bikash Kumar Senha, and Professor Malay Ghosh. We had three more lectures in the second session, which were delivered by Dr. G.P. Shamonto, Professor Nitish Mukhopadhyay, and Professor Karthik Sriram. The recordings of all these lectures are available in the official website of Calcutta Statistical Association, which is www.calcuttastatisticalassociation.in. In the current session, we will have four lectures. Today's lecture will be delivered by Professor Ashish Kumar Chattopadhyay from University of Calcutta. The next lecture will be held on 8th June and will be delivered by Professor Monisha Pal from St. Xavier's University, Kolkata. The third lecture in this session will be delivered by Professor Shuli Mukhopadhyay from IIT Bombay on 20th July, and the final lecture in the present session will be delivered by Dr. Shurupa Chakraborty from St. Xavier's College, Kolkata on 10th August 2024. This lecture series is being organized by Calcutta Statistical Association with the aim to enhance our understanding and passion for statistical analysis by exploring the fundamental concepts, practical applications, and exciting advancements in the field of statistics. Please allow me to share a few words about Calcutta Statistical Association. It was established in 1945 by a group of statisticians who were member of the teaching staff of the Department of Statistics, University of Calcutta. From the very onset, the objective of the association has been to promote activities related to statistics. Using its limited resources, the association continues to play a key role in developing statistics. The association has always focused on advancement and dissemination of knowledge of statistics through its various publications. The Calcutta Statistical Association Bulletin, from the very beginning, paid due attention to quality of articles. Today, the bulletin is highly rated by the international community of statisticians. Since 2016, Calcutta Statistical Association Bulletin is being published by Sage Publications. The association regularly organizes lectures by eminent scholars from India and abroad. Since 1991, Calcutta Statistical Association, jointly with the Department of Statistics, University of Calcutta, is organizing an international symposium on probability and statistics every 3 years. This year, we will have the 11th edition of the International Triennial Calcutta Symposium on Probability and Statistics from December 27th to 30th. For all the details about the Triennial Symposium and to be a part of CSA, kindly visit our website www.calcuttastatisticalassociation.in. It's now time to introduce our speaker for today. We are really honored that we have with us today Professor Ashish Kumar Chattopadhyay from Department of Statistics, University of Calcutta. He has served as the Pro-Vice Chancellor of Academic Affairs and also as the Interim Vice Chancellor of the University of Calcutta. Professor Chattopadhyay got his doctoral degree from University of Calcutta after completing BSc in Statistics from Presidency College, Kolkata, and MSc in Statistics from University of Calcutta. His current research interests include demography, statistical computing, astrostatistics, multivariate analysis, and data mining. He has more than 100 published research papers to his credit in reputed statistical and interdisciplinary international research journals, and has also been the author or co-author of 5 books. Professor Chattopadhyay is one of the associate editors of the Journal of Applied Probability and Statistics. He has successfully guided 10 PhD students, of which 7 have already been awarded the PhD degree. Professor Chattopadhyay has served as a visiting scientist and professor in Institut de Planétologie at the Astrophysique de Grenoble, France, Concordia University, Canada, and Southern Queensland University, Australia. He was also associated with the Indian Statistical Institute, Kolkata, as a faculty member. Professor Chattopadhyay was selected as Fellow of West Bengal Academy of Science and Technology in 2017. He was nominated as Statistical Expert in Task Force Committee for Big Data Science on Astrophysics, Government of India in 2017. He was selected as Fellow of International Astrostatistics Association in 2016. He was an elected member of International Statistical Institute from 2016 to 2022. He was selected as visiting associate of Inter-University Center for Astronomy and Astrophysics, Pune. Professor Chattopadhyay was selected as a sponsored member of International Union for the Scientific Study of Population, supported by UNFPA and French Ministry of Foreign Affairs for the period 2005 to 2011. We are really grateful to Professor Chattopadhyay for accepting our invitation to deliver this lecture. May I now request all the participants except the speaker to kindly turn off their microphones. Please write your questions to the speaker in the comment box only. We'll have a discussion session at the end of the lecture. I'll now request Professor Chattopadhyay to start his presentation.
Good evening. Thank you, Dhiman. It is really a pleasure to be here to say something before you. Although I am associated with Calcutta Statistical Association for a long time, but I must thank at present the young members under whose initiative this outreach program started. And I think they will, these different activities of the association will go on with the help of them. So my today's lecture, that is according to the suggestion of the group, this is for mainly for the undergraduate students, and I will try to restrict myself to in that domain so that they can follow this with a few extensions. And if there is any problem, I request all of you to ask question in between or write in the chat box if you have any difficulty. But I think it is a very simple talk and you can easily follow this. So I am just going to the presentation. Let's see. Can you see it? Is it visible?
Yes, sir. It is visible.
And if I move, it is okay, no?
Huh.
Thank you. So my today's talk is on data types and related analysis. You see, when we have started our journey at the undergraduate level, we started with the topics like descriptive statistics, probability theory, and after a few classes, the statistical inference, sampling distribution, like that. And still at this moment also, I feel that those were the courses which helped us to build up our career. So those are the basic pillars of the subject. So it is necessary to know those things very clearly to start a journey in the, say, the path of statistics. And while starting that, when after the completion of the post-graduation, all the courses have been taught and we have knowledge of the different topics separately. But what I feel that when I started application and my research, what I feel that this how to properly manage all these parts together to complete a statistical experiment, that is very important. Because a complete statistical experiments has different parts, as you know, starting from the setting the objective, selection of the variables, then collection of the data, then preparation of the data, identifying the proper data analysis tools, and finding the results, and then interpreting the final results. So this is a long path, and each and every thing should be done properly in order to explain the inherent features of the data. That was the target in a statistical experiment, according to my understanding. Now, to complete this part, the initial part is most important. That is your objective. What is your objective? And depending on the objective, you have to decide about the variables under study. And then you have to collect data. Now, my talk will start from the point where we have data and we have to decide about the data types and the possible modeling for the analysis. That is today's, mainly I will concentrate on this, but particularly on the data types. Okay. So as I mentioned that we need the data, and this is very important, that term relevant is very important there, because you have to have the relevant data, otherwise your analysis will be wrong. And you have to decide from where you will collect the data. I'm not going into the details, but I'm just mentioning the points. So this data may be primary data, that is, you may collect the data for yourself. It may be, you may have the data from other sources, that is secondary source. And you may have a population survey, that is a complete enumeration like our population census, but which is very rare, which is very expensive, although this is the most accurate thing, and it is time consuming also. So you avoid this, we go for, and one may also use a secondary data which is collected by other sources and listed in some reputed publications, and you may have data from them. Anyway, so these are the basic things, how one can have data, relevant data. Now I am just going to an example of data. So this data is the purpose, this US data. The purpose of the study is to build up a model to predict the chance of a firm to become bankrupt. Okay. So this is the objective. Now for this, we have data on some variables, and these variables are listed here. So the first one is X1, which is the retained earnings by total assets. X2 is the earning before the interest and taxes by total assets. X3 is the sales by total assets. Y is the response, that is 0, it is bankrupt, and 1 if not. And C is the place where this is situated, and C is the category according to the assets. Say A1 is minimum, A1, A2, A3, etc. So our target is to prepare a model. So just by looking at the data, I think you have started thinking what type of modeling it should be, what should be the nature. So before going into that part, we have to first decide about the data type. It is very important, because depending on this, the analysis totally changes. Okay. So if you look at those variables X1, X2, X3, so you know that these are all the continuous type variables, you can take any value. And here the place, which is called a nominal variable, take some values at different places. So California, Pennsylvania State, Washington. Sure. And depending on the assets, there are some categories of the companies, say 1, 2. And the response is Y. So either 0, that is bankrupt, and 1, that is solved. Okay. So just by looking at this value.
Please full screen your presentation.
Okay.
On the current slide.
Is it okay?
Sir,
আসলে ফুল স্ক্রিনটা আসে না সব সময়, দ্যাটস আই নো দিস।
ঠিক আছে স্যার, করুন আপনি।
আসছে কি এখন? আসছে
না স্যার।
না স্যার,
ছোটই আসছে।
হ্যাঁ হ্যাঁ
ঠিক আছে, আমি ছোটতেই থাকি।
ওকে, হ্যাঁ
ঠিক আছে, করুন স্যার।
আমরা অবশ্য বুঝতে পারছি না, বড্ড ছোট দেখতে পাচ্ছি না।
আমি কি পিডিএফটা আমি চেষ্টা করছি, তাহলে একবার পিডিএফটা গিয়ে যদি
স্যার এটা প্রেজেন্টেশন মোডে গেলে মোস্ট প্রবাবলি হয়ে যাবে।
নিচে এটা প্রেজেন্টেশন মোড আছে, ওই 63% বাঁদিকে যেটা রয়েছে,
প্রেজেন্টেশন মোডেই তো আমি রয়েছি।
ও,
আমি তো প্রেজেন্টেশন মোডেই আছি।
স্যার ফ্রম দ্য বিগিনিং লেখা আছে না, ফ্রম বিগিনিং।
হ্যাঁ না, ফ্রম বিগিনিং দিচ্ছি, কিন্তু ওটা অপশনটা যাচ্ছে না।
ও আচ্ছা,
স্যার আপনি একদম লেফট কর্নারে উপরে দেখুন স্টার্ট প্রেজেন্টেশন আছে, ওখানে একবার ক্লিক করে দেখতে পারেন। যদি প্রেজেন্টেশন হয় তো বাইরের লেফট সাইডটা সরে যাবে আর উপরে স্ক্রিন বর্ডার গুলো সরে যাবে। একবার ট্রাই করে দেখতে পারেন।
Visitors, recording, presentation. না, এরকম কোনো অপশন
স্যার ছেড়ে দিন, আপনি করুন, আমরা বড় করে দেখে নিচ্ছি স্যার।
হ্যাঁ স্যার, ঠিক আছে, কন্টিনিউ করুন স্যার, ডিস্টার্ব হয়ে যাবে।
আমি একবার এটা দিয়ে দেখি, পিডিএফ অপশনটা দিয়ে দিচ্ছি। এটা কি আসছে? Is it okay?
Yes sir,
Yes, sir, it's
it
visible.
is better. হ্যাঁ।
It's better. Okay, so just we're discussing about the types of the data. So now I am going into the details about this nature of this data. So this is a simple an example, and you know that for modeling this, of course, you will think about the logistic regression, but for the other variables, you have to make some necessary adjustments also. So what is data type? So we start with a binary variable. So we know that the binary variable has two possible outcomes, say two possible states rather. And for example, say gender, with a little exception, there are mainly two possibilities are there, male and female. And say smoking habit, which is smoker and non-smoker, etc. So here we have, in case of binary variable, we know that the number is secondary. Primarily, we have two possible states, and we generally denote these two states by either 0 or 1. 0 for one and 1 for the other. But the thing is, here also we have to if we go into the details, then we can identify two types of binaries. That is, one is called a symmetric binary and the other one is called an asymmetric binary. What is the difference? In case of asymmetric binary, these two options, that is 0, 1, they are not same as the symmetric binary. Here, we divide the data forcefully. That is, for example, say the color of flower. If we divide into two groups, that is, one is red and the other is not red, and or say the blood group, say A positive and not A positive, then here 0, 0 matching and 1, 1 matching, they have separate meaning. Because 0, 0 matching means that is only one possibility is there, but here 1, 1 matching, we have say not red, includes many possibilities. So here, this matching has no meaning. So when we go for the data analysis, these two types of variables should be separately treated. One for the symmetric binary and other for the asymmetric binary. That point is important here. I will show some continuous table also later. And next is a nominal variable. As you know, the nominal variable, only some there are values. We numerically code it, but the numbers actually has no meaning. It's arbitrarily chosen. So for nominal variable, the order of listing of the category is also irrelevant. We have some values. For example, say the defective, non-defective. So here ordering has also no meaning, and say 0, 1, 1, 2 also has no meaning. Simply they are nominal variables. Then the ordinal, the difference between nominal and ordinal is that in case of ordinal, there is some inherent ranking in the different categories. For example, say the military rank, or maybe we are doing some survey, and these categories may be called, say, if you only ask a particular person his attitude, then he may be very liberal, moderate. So there is inherent ranking there. Okay. But here also, this ordinal variable may be of two types. It may be discrete ordinal or it may be a continuous ordinal variable. And the continuous ordinal variable, the measurements are continuous. But actually, there is a values also, there is no meaning. I'm giving one example here also. So this type of data arises from when the original data were roughly on an interval scale, but contains some cross errors. For example, suppose we are interested in the running time of the race. This is some values are there, the running time, but actually these actual times had no meaning here. For example, let's say exact running times are in the sense that suppose the last runner, if you see that the first one has already reached the target, then completing the remaining part, he may just walk. So in his case, that time has no meaning. Here only we're interested in the ranks. Okay, so this type of variables, these are sorry. So this type of variables, these are known as the continuous ordinal variable. Okay. Now, and then we may have the interval scale and the ratio. That is, interval scale means there is a natural, this presence of zero is arbitrary. We impose this zero there, but this may be negative or positive. And the differences have this, for example, say the temperature in Celsius or Fahrenheit, the interval scale, they are ordered negative or positive constants, but no natural zero. Differences make sense, but ratios do not. That is in the interval scale variable. And then another type that is called the ratio data, which is defined as a quantitative data having the same properties as the interval data. But here we have a zero, absolute zero is there. For example, say the world population for a certain time period. So usually, you know that for a ratio variable, this for which the distinction between 2 and 20 has the same meaning as in the distinction between 20 and 200, like that. And usually we take the logarithm transformation for such type of data. Alternatively, we may treat this as continuous ordinal data also. Say, for example, the height, the speed. Here we have some natural zeros, the absence of height or speed. That is, and the values are all positive, as I mentioned. And here we can, for example, the ratio, it may be in different scales, but the ratios are same ratio will be here. So that is called the ratio variable. So these are the one direction from which you can look at the data, that is nominal, ordinal, interval, and ratio. The next type of distinctions, all of us we know, that is discrete and continuous, of course. So this discrete and continuous, they are quite known, as all of you familiar to this type of distinction. But one thing is important here. This discrete, to identify a variable as discrete or continuous, that is according to their inherent nature. But the actual observation, say height, suppose the height of a particular person is 5 feet 10 inches, that is a discrete value. The values are actually discrete, but this is actually continuous variable because of the reason that this discreteness is due to the limitation of the measuring tape. Actually, actual height may be something more finer measured if available, and it may not be exactly that, and it may lie within a small interval also. So that is depending on the nature, we say this is a continuous variable, and say the number of wrong entries in a passbook, which may be 0, 1, 2, etc. That is by nature is a discrete variable. So this is another type of distinction between and the type of the variable, that is discrete and continuous. Okay. Then I'm slightly deviating, so I am just going for a time series data. So data distinctions may be in different dimensions. You may look the data in the different forms, different types, different directions, different over time, cross-sectional, etc. So that distinction is also important for proper modeling of the data. Okay. So that's why I'm talking about this type of data also. So as you know, time series data that is recorded over consistent intervals of time, and the cross-sectional data consists of several variables recorded at a particular time point. And we can pool the both together The main distinction is cross-sectional data and time series data is that the cross-sectional data focuses on multiple variables simultaneously, and time series data concentrate usually on one particular variable over time. It may be bivariate or multivariate time series also, but there the observations must be correlated in some sense, and they must be observed for a long period of time. So that is the difference between the cross-sectional and time series data. An easy example may be the time series data is the rise and fall of the temperature for a particular day. If we track the data for the specific temperature for our, say, hourly data, and you have a 24 hours data, and that can be considered as a time series data. And if we go into the details and some minute things, then there may be some distinguished cross-sections, distinguished clusters also there inside the time series of cross-sectional data, some combinations also. So one may be that the time series cross-sectional data, which TSCS, which is known. The time series cross-sectional data contains time in order observations across different units. When you carry out this, we assume that the same type of causal process occurs in all the units. This is an example is here, which is easy to follow. There is a causal, suppose we're interested in 3 developing countries, say Kenya, India, and Brazil, in their GDP values, and for 3 successive years, 2015, 16, and so here, the study group of entries, that is their developing countries, some causal relationship is there. Maybe enough more other countries, developing countries also may be there. Here I have a small part of the data set, that is Kenya, India, Brazil, over a small period of time, say 3 years, 15, 16, 17. So this is termed as a time series cross-sectional study. And in general, there is, I'm doing the next slide, that is, better we come here. This is a panel data. Okay. Panel data is a type of data which you see, this is the data for the different countries and for the time periods, say 91, 92, 93, and 2001. For a small period of time, we have studies, suppose a large number of countries and the 3 variables, namely the personal disposal income, the personal expenditure, the median household income for all these countries and for those years. So there are a large number of countries in the data and only 4 time points. So apart from the variable, the number, the data structure confers upon the variables 2 dimensions. They have a cross-sectional unit of observation, which is in this case the country, and they have the temporal reference, that is T. So the error term has 2 dimensions here. One is the country and the other one is the time period. So there is a little distinction between these 2 types of data, that is panel data and time series cross-section data. And logically, this TSCS data looks like panel data, but panel have large number of cross-sections with each unit observed only for a few times, that is small t. So TCTS data are reasonable size t and not very large n. So for panel data, the asymptotics must be in n and t is fixed. And for TSCS data, the asymptotics must be t and n is fixed. Although it may not be clear to all of the students, but this is the concept behind the data. I'm slightly indicating the possible ways. And another type of data, which may be termed as the directional data or angular data. This is also actually this is a different branch of the statistics. A number of books are coming related to the analysis of this type of data, because everything is different. It is not a linear scale, which is a minus infinity plus infinity. So this is an angular data, 0 to 2 pi. And for circular data, the angle theta, this is usually we specify either from minus 180 to plus 180 or from 0 degree to 360 degree. And for the spherical data, this is represented in polar by, say, latitude, longitudes in the, say, on the Earth, or it may be the right ascension and declination in the universe. So there are different types of expressions which relates to this directional data. And you see here the difference. We know that 1 and 359, they are much separated in linear scale, but the 1 degree and 359 degree, they're very close in angular scale. And say the one possible example here, sorry. One possible example here is, say, the movement. You see that the random sample were taken to an experimental site at sea, where if the experimenter was like this, that is orientation of a certain type of turtle. 76 of the turtles, they travel, were recorded, the data measured in the conventional way of bearing clockwise from the north. So their movement, that is actually directional data. And if you go for the analysis, you have to treat the data type as directional, say angular data, which may be circular or it may be spherical, etc. So you see that so long as I have explained different types of data, where you're looking at the data from the different angles. But the most important part is when you will go for the analysis or will go for the modeling of the data, this data type is very much important for proper modeling and with proper analysis. And you have to readjust, you have to make transformations, you have to use some new models there. So now I'm going to suggest one continuous table to explain that symmetric and asymmetric binomial situation. So that is a relationship between, say, nominal, ordinal, generally the categorical variable. So you have, say, x and y denote the two categorical responses, x with, say, I categories and y with the j categories. So a rectangular table having I rows from categories of x and the j rows from the categories of y, that will give you the continuous table with the ij possible values. Now, I'll give you one example. So this example is to study the relationship between the use of seatbelt, that is either using it or not, yes or no, and the outcome of an automobile crash. That is, after the crash, if it is noted that whether the driver or the other passengers, they were using the seatbelt or not. The data were recorded and they're presented in the following table. You see that the use of seatbelt, yes, no, and the result of the crash, that is non-fatal or fatal. And just by looking at the values, you see here the matchings, that is yes and non-fatal, yes and fatal, no and non-fatal, no and fatal. So the values say yes and non-fatal, that is significantly high. Even the match with no and fatal, that is also very high compared to the cases that is non-fatal and no, and yes and fatal. So just by looking at the table, of course we have some measures also, just by looking at the values itself, we will say that this use of seatbelt has a significant effect on the fatality of the accident. Okay. Now, obviously, here the first variable, that is the use of seatbelt, is of course a symmetric binary variable. Only two possibilities, either you use or not. But the second variable, that is the fatal and non-fatal, the non-fatal part maybe have different subdivisions also. The degree of it, how fatal it is, that may be introduced. So it will, in that case, it will become asymmetric binary, and in that case, that matching value may not be has significant meaning also, the 128. So if we think about some possible measures here, so for the symmetric binary, the agreement is simply that both A and D, they corresponds to the agreements. So A plus D divided by A plus C plus D, and these agreements is like that. But in case of asymmetry, that value D actually has no meaning at all. So in that case, the agreement should be A by A plus B plus C, and disagreement will be the same, that is B plus C by A plus B plus C. So you see that these are some points to be noted while you look at your data and you go for your proper analysis. That's why I'm just highlighting those points, because when I have gone through the different statistical experiments, I have faced those type of problems that was very severe. These are very simple things, but if you go further, some severe problems may also come to model the data, to present the data, to code the data properly, depending on the nature of the data. Okay. So we know, as you know, that the simple situations, there are some distinct measures, and for the say, angular data, these are actually some measures of mean direction and the dispersion of the data. In this talk, I will not concentrate on the measures and the analysis. I will try to concentrate on the types. That's why I'm not going into the details there. But so till now, I have not. So this is actually, in short, we can say that if you look at the data, there are different possibilities in the data set. And even we can look at we may have a univariate data. We may have, say, the bivariate data. We may have the multivariate data. We have a number of variables together, and your analysis should be developed in following the proper direction and proper information with you. Now, till now, during my discussion, I haven't mentioned any diagram. You know, the diagrams these days are very important for the presentation, proper presentation of the data. Even these diagrams also heavily depends on the data type. As you know, I think some of them is very much known to all of you. I am tempted to show one of them because it's a new one, and I am very much interested just by looking at this. Before that, there is a small data set example here. I'll be, if the students present here, if you write the answer in the chat box, I'll be happy, because then I will feel that, yeah, my discussion, you have, that you have followed the discussion, it is easy to you. So you just look at the data. But is the data? Data is the weights of solid wastes generated per year in USA during the period in 1960 to 2000. Actually, this is a part of the data. Actually, you have 41 such data points. And this is the data that is here. And the two variables are X and Y. X is the paper waste and Y is the plastic waste. This is very simple data type. And just you write what type of data it is you fill for the analysis. You just write, you may write it in the chat box, and finally I will find out that. Okay, that's fine. So up to this, I have discussed some of the examples and different types also. So what I'm telling about the diagram. So one diagram which is very popular these days and which is relevant for the big data also, that is a chord diagram. I know most of you know this, but it is very interesting to follow such a diagram. If you look such a diagram, you know that a chord diagram, this is a graphical method of displaying the interrelationship between data radially around the circle. It represents the flow or the connections between the several entities. And it is primarily, it was started in 2007 by New York Times for a graphical presentation of the data. I'm just showing you one example of this data. Say, sorry. Oh, I have to go to the previous one. 1 minute, I have to go back. Okay, so this is a chord diagram. Is it visible, Diman?
Yes, sir, it is.
Okay, so this is a data, a Dutch data, This is data for the survey was like that. They covered a large number of people and asked about their mobile phone, from which company they're using, and the company of the previous mobile, whether they have shifted from other company to the new company. That was to feel which one is most popular in the market these days. So you see in in this diagram there are say 8 such mobile companies, mobile phones. These are from Sony, Samsung, Nokia, LG, Huawei, HTC, Apple, and others. So these 8 such companies. So along this circumference, you the percentage of share of the companies, these are mentioned. That is, you see that Samsung is the maximum percentage. The colors corresponds to the different companies. So this part corresponds to the Samsung. So this color is Nokia. This color is LG. This is Huawei. This is HTC. And this is Apple. And this is other. And this is Sony. You see that these small hills corresponding to each such color, this presents the users who are very loyal. They continue their brand. So Samsung user, they're continuing the Samsung phone. And these chords actually, they show the flow. See, this part shows the percentage of Samsung who has moved to Nokia. And this part gives you the percentage of Nokia users who have shifted to Samsung. Okay, so you see that you can easily understand there is a large move from the Nokia to this Samsung, and similarly for the other brands. Okay, so just by looking at this diagram, you can easily say many things about this particular data type. That is, what percentage the market share of each of these companies, how the popularity of the company is changing over time. And if we have a number of years, then it will be more clear. That is, if you look at the data, if we have a number of years, say, then you can compare also how they're changing over time and what is the nature of the movement. So these are some of the diagrams gradually coming into the market with the changing nature of the data, that how one can directly look at the data and tell about the inherent features of the data, to directly say the nature of the data. So it's interesting. This is interesting to me because of the reason that it represents the flow also, so which is difficult to present in a diagram. Okay. So anyway, so now I'm going back. Yes. Okay. Now, finally, I'm going to present one data set. Actually, we have worked with this data, and in many of our works, I have used this data set. This is a primary survey data, the medical data. So I am presenting this experiment here to show you how one can look at the data type, how one can quantify the data, and how one can model the data by looking at the nature of the data, and that is most important here. So very often is the lack of adequate direct measurements. Scientific data are recorded according to a well-defined ordinal scale. So here all the variables, mostly they are either ordinal or nominal, in which we are interested. So commonly in the social and behavioral science and increasingly in epidemiological research, these multiple discrete indicators, they're utilized as responses in lieu of an obvious single measure. So sometimes these multiple indicators corresponding to a subject are each rated with natural orderings. In such cases, the ordered responses of the subject are likely to be positively correlated. So that is the scenario behind. Now, this particular study is a oral hygiene study. The study was like this. What happened that some of a few doctors, dentists, they came to discuss with our group that they were interested to study the efficacy of some of the brushes commonly available in the market, and efficacy in the sense that how the removal of stain from the teeth. That is the thing. So which one performs better? So that's why they have started a trial, a clinical trial, with a group of persons. And so our target was to quantify the values and to prepare a model and finally to analyze the data. So that was the task. Okay. So this is carried out by a dental and the medical college in and around Calcutta. The survey covered 220 individuals consisting of students and staff members of the medical college, selected at random, irrespective of age, sex, and oral hygiene. So a detailed history of each sample individual recorded with prior to the beginning of the study to collect the information like, say, age, sex, occupation, food habits, smoking habits, tooth cleaning habit. So these are the variables under study. And they are also educated regarding the importance of maintaining oral hygiene. That was the background. And so what was the study? In oral hygiene studies for each subject, the reduction of plaque formed on, actually, when we look at the data, according to the doctors, there are 6 important teeth on which they studied the stain. So they know according to their language, the importance is defined. So there are 6 such teeth. That is important. That's why this is rastered data. The 6 teeth of a particular person. And incidentally, the reduction in the thickness of plaque for subjects are usually recorded as belonging to 4 different categories. That is no reduction, that is 0, slight reduction, that is 1, moderate reduction, that is 2, and worst reduction, that is 3. The actual objective is to study the cleaning efficacy of the brushes with different designs. You know that these days different design brushes, say the zigzag, plain, soft, something like that. So different designs are there in the market, and which one is performing better, that was the target. So clearly such data can be considered as a set of data where the categorical responses for those 6 teeth of an individual are interdependent. And we have considered the difference, that is the pre-brushing score minus the post-brushing score. So these are the 6 teeth under consideration. As you know, I'm not, because we have no idea regarding the names. So there's 6 positions there, they have shown us. These are important 6 teeth, and which will denote by, say, 1 to 6 statistically. Since plaque is colorless, it was identified with a solution prior to scoring, and thus in this study, plaque was considered as stainable. Now, 6 commonly available toothbrushes in the market were selected for the study. Each individual was given a total of 6 different designs of toothbrushes to be used during 4 months long clinical trial study. The final data set, essentially based on a crossover trial, gives the differences of pre minus post brushing scores for these 220 individuals corresponding to 6 different types of brushes. The genders, food habits, and smoking habits of the 220 individuals are also supplied. Now, this is the how to prepare the data set. I'm just going to explain this part. So this is the data corresponding to a particular individual. What are the values? You see, this is the data for a particular tooth, one tooth data for the 6 brushes, 6 types of brushes, and for one particular tooth here, and the 6 brushes are mentioned by these ones in the corresponding position. So the first 6 columns corresponds to the brush indicator, and the last 3 columns, among these last 3 columns, totally there are 9 such columns. The 7th and the 8th, the 7th and 8th corresponds to the food habit, that is vegetarian or non-vegetarian, and the smoking habit, the smoker and non-smoker. Actually, these are the variables which affect the stains. Other variables, they do not, so we haven't considered those. So now, if we look at the data set, so coding is most important here. If you look at the data set, you see that since this in the 7th position, this is 1, so the person is a vegetarian. All over, this is 1. The person is a vegetarian. And in the 8th position, this is 1. So the person is a smoker. And the last column, this gives the reduction. That is the difference between 1 and 3, and 3 and 0, 3 and 1, say 2 and 1, something like that. So this gives the amount of reduction. And this row corresponds to the 3rd brush. This row corresponds to the 5th brush. This corresponds to the 6th brush, like this. So there are 6 such brushes. So this way we have prepared the data set, and we have 220 such individuals, the total data set consisting of those values. Now, I will not explain the analysis here because it is not really it will be appropriate for this for the students. But I am just mentioning that how one can prepare the data set depending on the data type. That is the important thing to mention here. That we have seen that the reduction of the thickness of plaque is not influenced. This is actually our assumption, and we have also seen it that on the baseline thickness, that is, for an individual with a low initial thickness, the reduction remains virtually same as that for an individual with a high initial thickness. That was the assumption, and they supported it. And I will show you one table because after the preliminary exploratory analysis, we found that, yeah, it is possible to go for some statistical interesting part of the analysis may be started, because from the this exploratory part, it is clear that one brush is working better. If you look at this data set, you see that these are the brush types. There are 6 such brush types, and this is for non-veg, this is veg, this is non-smoker, this is smoker, and these are the mean values. You see that here also this mean value is the highest corresponding to all the means. Here also this mean value is the highest corresponding comparing to the all other means. So here also this is highest, and here also this is highest. So we can say that this third brush is performing better compared to the others. I'm not mentioning the brand because it should not be unethical, but there are different brands, publicly available brands were there, and one particular company brush is working better, such a study. And you see that after that, after having that amount of information, we have gone for a detailed statistical analysis, and starting from the high dimensional likelihood, and we applied some Bayesian approach and some non-parametric approach also. And after that, we use this data for some other works also. It is very interesting data, and you can use this data in different forms. So I think up to this point, it is clear to you how one can look at the data, how one can study about the nature of the data. The data type is so important. So for the proper analysis of data, you have to go look at the data properly and think about the possible outcomes also. So thank you all for attending this one. And that the data set I have shown you, that is very simple. That is a bivariate time series data. Okay. Thank you. Thank you all.
So we'll now have a question answer session. Students are asked to put their question in the chat box. So I will read out to the speaker. If there is no question,
can I raise a small question?
Yes, sir.
In the last data set, Ashish,
Sir.
on oral hygiene,
Right.
since you showed in the last table mean as also SD of reduction,
Right.
and you spoke of reduction in 4 categories,
Right.
how did you convert the categories to scores?
Which category is 0, 1, 2? That is the difference. Pre-brushing score and post-brushing score, the difference in between. Suppose the from the pre-brushing, the says the score is say 2, and the post-brushing the score is 1. Then 2 minus 1, 1 is the reduction. That is the score.
Or difference in codes.
Difference in scores.
And the codes are 1, 2, 3, 4 for the 4 categories.
0, 1, 2, 3.
0, 1, 2, 3.
Right.
There are 4 categories.
Yeah.
For reduction.
Right.
We have assigned them 0, 1, 2, 3.
For reduction, no, for reduction for the stain level. If I think if I go there, sorry. If I go there, yes. Can you see, sir? Is it? Can you see it? That is, no reduction is 0.
No. Okay.
Slight reduction is 1. Moderate reduction is 2, and worst reduction is 3.
This assignment of numbers 1, 2, and 3, 0 is understood.
Yeah.
There should be no debate on assigning the value 0
Yes.
with no reduction.
Right.
But to the other 3 categories,
Yes.
assigning values 1, 2, 3,
Yes.
as you can understand, is a bit arbitrary or a
Right.
bit subjective. Is it necessary to carry out something like a robustness investigation? If I change those 1, 2, 3 to some other values, how do the ultimate inferences get affected?
Maybe, but I think it will not, because whatever, since there is some uniformity, I am taking the difference. So if I change the values, the effect of the difference, I think, will remain the same.
You can look at it. Maybe
Yeah.
since the data are available with you,
Yes.
you can look at it. Instead of 1, 2, 3,
Yes.
I'm talking of the reductions only. There is no debate on 0 reduction, definitely. But on the other 3 scales, instead of 1, 2, 3, if somebody assigns, say, 1, 2, and 4, or let's say 1, 3, and 6, something of this sort, how do the differences among the 6 brush design types get affected? That you can examine possibly. Just a suggestion.
Sure.
No comment.
Thank you. Any other question?
so can you explain the chord diagram again?
Or diagram?
Yes.
Yes, chord diagram is like this. Suppose you have data. For this particular example, you have the number of users for 8 types of phone. And so you know the numbers, then you first convert them into the percentage. Okay? What percent of users using, say, Samsung, what percentage of user using some other phone, like this. And on the according to the circumference of a circle, you place those values as the market share on the circumference. And then after placing this, then you draw the chords. You have also the information that a particular user, which particular type of brand the last phone, his phone is from which brand, that is also known to you. So you know that what percentage they have shifted from one brand to the another, and use that number to draw the chords. That is the two ends of the chord. One end, depending on the use. Suppose there is a chord in between Samsung and Nokia. So the one part of the chord which touches Samsung, that shows that percentage of users shifted from Nokia to Samsung, and the other end which touches the Nokia side, that chord, that percentage indicates the percentage of users shifted from the Samsung to Nokia. That is the idea. So for other brands also, the same chords they draw. And the users who are very loyal, that for them the small hills were there, that is the oval shaped things, that they are maintaining the same brand. That was the idea. Okay. Is it clear to you?
Yes, sir. Thank you. More or less. So if there is no question, so
Some
there is
question.
a question. Yeah. So let me read out this. Sir, I know it's unethical to ask the number 3 bar name, but sir, could you please tell me the class name and model?
No, you see that these all the companies are multinational, so just mentioning one name in a particular, it may come a different result from other clinical trials also. So I think I should not mention this here. So anything else?
Anything statistical thing related to
Hi,
statistics?
Professor. This is me, Junaid. I had a little query regarding this. You were talking about this binary data. Sorry, and then binary data, and then symmetry and asymmetry in the data set. So if it is like, we are kind of dealing with the asymmetry in the binary data. So
Yes.
like in the asymmetry part, which is like the required 0 part or one whatever the category it is, like if there is some underlying categories, like what kind of analysis should someone go with, like if it is an asymmetry?
So the main thing here is the difference between symmetry and asymmetry. You have to ignore the matching part with the asymmetrical side. That is the part where we have several options you have taken together. The matching of that part has no meaning. So that you have to take into the mind. So while considering any such measure, you must avoid that value, because that value will be confusing. This will not give you any result. So you may develop different types of measures. Whatever all the measures will be there, you have to just avoid that D. That is the matching corresponding to the 0, 0. That is where we have coalesced many groups, many possibilities together. That matching has no meaning in the asymmetric case.
So considering matching, like if I'm really interested in that particular category, let's say 0 is that particular category I'm interested in, and the rest of the categories I'm not really interested, not that we interested, but my point of target is actually exploring the 0 part.
Yes.
So what way can someone do this analysis?
Yeah, that is, then you artificially divide the data into 2 parts. One part The 0 part where you are interested, you take that part in 0 and the remaining part in 1. Then, and you work with that part only. You can ignore the other part in that case.
So, like in that case, like I'm dropping like maybe some selection bias may appear, and then I'm kind of cutting sort of like dropping some observations from the original data set. So, how would that be a problem in that particular case?
Actually, without looking at the data, it is difficult to say something. If you're interested, you may just send me a detailed mail, then I can tell you.
Absolutely fine.
What
So,
type actually, what do you want to? Okay.
Thank you. So kind. Thank you.
There is a question
Yes.
from Royston Anil Lobo.
Yes.
How can we analyze multiple selection items in a survey? Multiple selection of items in a survey. Multiple selection.
Can you please say what do you want to say?
Hello, sir. Yeah, this is Royston.
Yes.
Thank you for the session. What I meant was that in some surveys, we have options like select the following choices. So whatever we, for example, which ice, just for an example, suppose if I'm asking a survey that what kind of, what you say, ice cream flavors do you prefer? So I give them different, what you say, options, and they can select whatever options, more than one selection. So in such cases, how can we analyze what is the best procedure to analyze data from such questions?
That is, you're interested to know the flavor of the ice cream. Okay?
Yes, yes.
And you have several options of the flavors are there, and you have done a survey, asked the particular individual which flavor you prefer.
Yeah.
And some of them are answering more than one flavor.
Yes, yes, sir.
Okay, if some that may be treated as a separate. What I feel now, some other possibilities may be there. If more than one flavor, then that may be treated as a different category. At least liking two flavors together, liking three flavors together, liking one flavor, that may be treated as a separate category also.
Okay.
And then you analyze that way.
Okay, so that will be analysis will be like grouping them, for example, using bar chart, or if you want
That
to.
is the graphical presentation. You have to ultimately you have to do some proper analysis of the data. That is, you have to prepare a proper model for that.
Okay, okay, sir. Thank you.
There is no question.
Another thing, Professor. I just wanted to like, and I was a bit curious about this particular problem, like in exploring this different types of toothbrushes and the efficacy to remove plaques or stains. So this is essentially a problem of public health. Definitely, in India, public like oral health problems or oral hygiene is not being given so much of importance in terms of public health. But there are countries like Australia, Denmark, Canada. They are actually into this public health. They are considering this as a public health body. So I was just little curious to know the actual analysis that you have performed to actually like it has been cut short for this particular presentation. So
yeah, if you send me your mail address, I will send you the paper.
Oh, thank you. Thank you. Thank you. That is what I was just asking. Thank you. Once again, thank you.
Anything else? If not, I think Tuhin, are you there?
Yes, sir.
So I think we have just completed the no other questions are there. Okay?
So before ending this session, we have some announcements. So this is the first lecture of the third session of lecture series for statistics education Statistics for Education and Research. And we have the next speakers are Professor Monisha Pal, Professor Shivlin Mukhopadhyay, and Dr. Shilpa Chakraborty. We have the registration will be reopened from tomorrow again. Those who have already registered need not to do the registration again. Just before ending the session, we would like to thank the speaker, Professor Asis Chattopadhyay, for his beautiful speech. And we would like to thank all the participants across India. Hope we will meet again here on 8th June for the next lecture. Thank you.